Okay, so continuing on with this example. So here again, we want to solve for the value, for the x value that's going to make m parallel to n. So we want these two lines to be parallel. We want to be able to show that. So what we want to do first is, again, look at the relationship between the two angles that we're given. So we have angle x, and then this angle here, 2x. And then looking at the two angles, again, the first question I'm just going to ask myself is, do they both happen to be inside or outside of the parallel lines? And in this case, it's yes, they're both inside the parallel lines. Or sorry, I shouldn't say parallel yet. That's what we're proving by solving for x. So are they inside the two lines? Yes. So because they're both inside the lines m and n, we're going to use that vocab term interior. And then looking at the transversal line here, x and 2x both lie on the same side of that transversal. So when they lie on the same side of the transversal, the vocab term we want to use is consecutive. So these two angles are consecutive interior angles. Now, since we want to make m and n parallel to one another, if two angles are consecutive interior angles, what has to be true about their relationship in order for us to say that they're in fact parallel? So in this case, consecutive interior angles are supplementary when the lines are parallel. And remember, supplementary means that they are equal to 180 degrees when you take their sum. So that means that I need to show that x plus 2x is equal to 180 degrees. And then I'm going to go ahead and I'm going to combine like terms. I can combine together x and 2x. That gives me 3x is equal to 180. And then I want to isolate my x, so I'm going to divide by 3. And so x is equal to 60. And then again, I'm just going to go ahead, even though I'm not asking for this in the problem, I'm just going to go ahead and check my work really quickly. So every time I see an x in this original equation, I'm going to now substitute it back in for the value of 60. So 60 plus 2 times 60 is equal to 180. 60 plus 2 times 60 is 120, is equal to 180. 60 plus 120 is 180. So it is in fact true that 180 is equal to 180. This next problem here is just asking, is line AC parallel to line DF? So if we look at this problem and we want to see, are these two lines in fact parallel? Well, let's look at the two angles that are given to us. We have this angle here, which is 57 degrees, and then this angle here, which is 123 degrees. So looking at those two angles in terms of lines AC and DF, again, first question I always ask myself is, are these two angles inside or outside the lines? And in this case, yes, both angles are in fact outside of lines AC and then DF. So because they lie outside of those lines, the term again that we're going to want to use is exterior. And then the next question I ask myself is, if I look at the transversal, are those two angles on the same side of the transversal or on opposite sides or diagonal from each other? And in this case, they both do lie on the same side. If we think of the transversal here, like describing it, we could say that they both were above that line. So because they're on the same side of the transversal, we see that they are consecutive. So these will be consecutive exterior angles. And then think about what has to be true in order for two lines to be parallel. If they are consecutive exterior angles, what has to be true about that relationship? So these two angles should be supplementary to one another because they are consecutive exterior angles. And remember, supplementary just means that the sum of the angles are equal to 180 degrees. So I'm going to go ahead and check, is that true? If I take 57 and add it together with 123, do I in fact get 180? And I do. So when I added the two angles, I got 180 degrees. Then that means that yes, line AC is in fact parallel to line DF.